you graphed exponential functions. What's the relationship between exponential and logarithmic? They're what? Yeah. So if you kind of can graph one, you maybe be able to graph the other one. This is the one we can graph. So let's do that again for the 7th time in the last 2 days. If x is -1, that's a half. If x is 0, that's 1. If that's 1, that's 2. That's 2, that's 4. And we can graph that. -1's a half. 0 is 1. 1's 2. 2's 4. And we know that gets closer and closer to that asymptote there, where y is 0, but doesn't touch it. Right? So if y is log base 2 of x is the inverse of this one, graphically, what do? I reflect it over the y equals x line, right? So that's 0, 1, so I'm going to go 1, 0. That's 1, 2, so I'm going to go 2, 1. That's 2, 4, so I'm going to go 4, 2. And on the other side, that's -1 a half, so I'm going to go half, -1. And does that look like, let's use that color, a reflection over that line? The uppers. All right, domain. All real. Whoop, let me do that in green. Which green did I have? That one? Range. Y is greater than 0 because y0 is an asymptote. The pinky one. The log graph, which is the inverse of that one. How does this change again? Well, have a look. What's my domain? Everything greater than that. Excuse me. Okay? What does the range look like? Goes up forever, goes down forever. All real. And again, if you're like memorizing, maybe for inverse, you want to look at the pattern there. What's my asymptote? Not y equals 0, but x is 0. Kind of like the inverse, swap x and y, right? Okay. So yesterday, we graphed exponential. Today we're graphing logarithmic. But how the heck do you graph that? And again, I know some of you can just plunk that right in your calculator, use a log base 2 and graph it, pull up a data table, see what the points are, and go plunk, 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 and it's child's play. Even if you don't have log base 2, you guys can still graph this, can't you? Because you know the change of base rule. That is log x over log 2. You can graph it and you will see exactly that. So in the good old days, you really did have to do this. Did I word that properly? I don't think so. I think not, I did. But now with the graphing calculator, you can kind of cheat. Come in. Okay. All right, so pretending I didn't have a graphing calculator and I couldn't put that in and get a table and graph this, how would I graph y is log base 3 of x? Lewis. Shush it. This is it. Okay, well, I would find the inverse of that because I know how to graph that thing, and then I would take the inverse of that. So it seems kind of corny, but I'm actually taking the inverse of the inverse, which gives me back to this function again. Does that hurt your head? Kind of hurts mine too. I don't know how to graph that. I don't have a graphing calculator. I don't know how to graph this, but I do know how to graph that. So in order to graph this, I'm going to graph that. Okay, take the inverse of it, and then I'm going to take the inverse of that, which gives me what I'm trying to graph. So that's what this stuff says. All right, take the inverse of the inverse, and then some of these were there yesterday, they're going to be here today too. Maybe apply a couple of transformations along the way just to make it interesting. So, how do I graph this thing? I don't know, but let's take the inverse of it and graph y is 2 to the x. Have we done this before? I think we might have. Negative 1, 0, 1, 2. If that's negative 1, that's a half. 1, 2, 4. And then, I don't want that. That's the inverse of it. So I'm going to take the inverse of this, which is that. So quickly, I could make myself another table, but how about I just swap x and y? Make sense? Yeah. So I just took the inverse of the inverse. That's going to be a plot of this. Okay? Not so bad. Then I'm going to add 1 to y, and that will be this graph. Okay? So x is a half. Y is negative 1, but I want to add 1 to it. What's negative 1 and 1? 0. X is 1. That's x. But I want 0, but I'm going to add 1 to it. Okay, so I'm going to add 1 to everything in this column. I'm shifting everything up by 1. So 1, 1. 2, 2. 4, 3. Okay, do we see what this thing looks like? You bet. Now, does it look like this guy? Probably not, because I scribbled over it 20 times. Shifted up by 1. Let's make them both on the same page. It should, right? This point was here at 1, now it's at 2. Okay, this point was here at 2, now it's at 3. This was at 0, now it's at 1. Everything here, it's this graph shifted up by 1. Okay? All right? So now I want to graph. And this is what your assignment's going to be like. It's going to be like the same log function, just different shifts. Okay? So if you already got your table, because I've already got log 2x. Okay, but now what does this thing do? Yeah, is that on the x or the y? That's on the x. This was not on the x. That was on the y. So it went up 1. This thing's going to go right 1, right? So that's going to be on the x. Half, I'm going to go right 1. So now it's 1 1/2, negative 1. 1, but I'm going to shift that right 1 and go 2, 0. 3, 1. 4, 2. So now, where's the asymptote? Here, it was that. It didn't change this if I move it up or down, but if I move this right, then my asymptote should also move right, shouldn't it? Oh, I didn't even write it down here. Where's the asymptote? X is 0. Where's this asymptote? X is 1. Make sense? Because I shifted it all right by 1. Domain. X is bigger than nothing. X is bigger than 1. Okay? It's kind of like review for our midterm, isn't it? Transformations. Oh, there's going to be lots of transformations on the midterm. Okay? Observations. So, yesterday I told yous when we did exponential graphs, doing that, which did what? Moved it up to, how did that change the range? Remember what this graph looks like, this exponential thing? This is bigger than 1, so it's growth. Looks like that, okay? If I moved it up to, how did that change the range? Here, what's the range? Yeah, greater than 0, up forever. But if I move it up to, then, yeah, it did affect it, right? The range also went up too. Okay? And of course it changed the asymptote too. The log graph looks a little different. Okay, this is what we had yesterday. Today is this. So it's the inverse. So, guess what? I'm more concerned about the domain. Okay? Because if a graph looks like this guy, if I move that thing up, how does that affect the range? Doesn't. But it's the range that can, or sorry, the domain that can be adjusted here, just like it did with the last question. So, okay, I told you that yesterday. Today, transformations, x values is domain on logs. This is the one I'm concerned about. And this is really confusing. So you see that 5? Just so we don't get confused, let's cross that out and put a 3, because it's the same number. Okay? I don't want 2 5s here. What does this do? 5 units to the right. It did before, it still does. Just because it's a log doesn't mean the transformation's any different. So if this guy is shifted 5 units to the right, well, how's that going to affect my domain? It's also going to be shifted 5 units to the right. And that's where the asymptote is too. So again, for the 19th time, you know, if you're a biology person, maybe you're going to try to stick that in your head. And in this case, the other thing I was going to say was graph it and just see, but that's kind of a beast to graph, right? All right, what's the domain and asymptote of this? Does this do anything? When I vertically expand everything by 4, is that going to change domain or range? No, right? Log base 3, I don't care. It's a log graph, which kind of looks like this. But, and that's moving it 2 units up. So what? This is the guy I'm concerned about on the x, because I'm talking about domain. What's that going to do? Well, look up here. That's 5 units right. So everything was 5 units right. So now it's 8 units right. Okay? So that's the asymptote. Okay? And domain is everything greater than 8. And again, we're skipping this, but I should put that every time, okay? But I know even the answers don't have that, so don't worry about it. It's implied. So this then, is that 6 units to the left? Careful. Think about it. Someone's shaking their head. No. What do I want to do first? Do I want to factor that? Yes, I do. Remember this stuff? Log base 2, I want to take that out of there. This doesn't look like anything I know. But that does. Okay? So that is 3 units left. So now it's over here. Okay, same shape, just 3 units left. My asymptote is x is minus 3, and domain, x is everything greater than negative 3. Okay? Finally, not finally, but next one. That also doesn't look like a shape I want to look. I want to factor out that negative. And sometimes you'll put a bracket there, sometimes you won't. Doesn't really matter, just like before. But what does that do? What direction is that now? Yeah, it is. You know what? Let's prove it. I'm just going to pretend that's log base 10. I don't care. It's going to make the same shape. If you got log base 3 on there, be my guest. Okay? So I'm going to put in negative x plus 3. Okay, and again, it doesn't really show this part, but that is definitely plus 3. What does the negative do? Should have said that before I graphed it. Yeah, that's a negative on the x. So it doesn't look like this where I'm going 3 units to the right. Right? That's on the x. That's a reflection over the y. So that's why it looked like that. Okay? So the asymptote is still at x is 3, but this is flipped around the other way. It's all the values less than 3 for the domain. That's a flip over the y-axis. Well, that's it. No, this, remember, that is still applies. That's minus 3, so it's 3 units to the right. This is a reflection, right? So you can reflect it first and then move it 3 units right, which is what I told you to do, and which is what you should do, right? Reflections first, expansions, then translations. You still get the same picture. Okay? That's why, hey, if you got a tool, you use it. All right, how do I graph this guy? Same way. Only it makes a different picture because the inverse of that, excuse me, exponential, that's not growth, that's decay, right? Because it's less than 1. So make a table, okay? X, Y, negative 1, 0, 1, 2. What do I got here? I got a few stuff. I got a different graph. That should be good. Half to the negative 1 is the same as 2 over 1 to the positive 1, or 2. Anything to the 0 power is 1. It's a half. That's a quarter. Okay, but I don't want to graph the inverse. I want to graph the original function. So I want to graph the inverse of the inverse. So I'm going to cross that out and make it x. I'm going to cross that out and make it y. No translations here. Transformations. So x is 2. That's negative 1. If x is 1, that's 0. If x is a half, that's a 1. If x is a quarter, well, we know where it goes here. Maybe I should plot another point. What if x is 3? Now it's kind of getting tricky, right? 3, that would have been, no, I want to go negative 3. Oh, anyway. That's the shape. Should I plot that just to make sure? Yes, Mr. Watson. Log of x divided by log of a half. That's what that says, right? Change of base rule. I want base 10 because that is what I can plot on this guy. With any luck, that'll make the same picture, does it? Yeah. Okay. Now, this is other ways to make the same picture. Feel free to read them. Okay, but that's the way kind of, if you want to do it like that, be my guest, okay? You'll get the same picture. There's lots of ways to do transformations or whatever, okay? But that's the only one I'm going to do. So, again, I know you can cheat. And it says don't use your calculator, okay? You can, so this will be a minor part in the test. Okay? It's just, think like big kids. The harder you make this on yourself, the easier it may be next year, depending on what you do in life. Okay? Make sense? So this is probably going to be most of the focus on a test, this type of stuff, because I know those of you who are swifter with a graphing calculator and you spent the big bucks, it doesn't really help you too much here. So how do I find the inverse? Algebraically, swap x and y, solve for y. So that's what I want to do here. Y is an x log base 4 of y minus 5 plus 3. Wonderful. How do I solve that thing for y? Well, what can I do with that plus 3? Sure. Huck it to the other side, change the sign. I'm going to show you something new, guys, because you may be stuck at this point. I'm going to take both sides, not to the 4th power, but I'm going to put 4 as a base and make each thing an exponent. Why, you ask? Any guess what this becomes? And I say that knowing that nobody knows yet because you haven't been taught it. That's what that becomes. I'll show you why in a sec. It's actually in tomorrow's lesson. I know, going a bit backwards in our book. So anyway, to solve this for y, what do I do with that 5? Huck it to the other side. Okay, that's it. Not too bad. Once you get around this funky thing that I just showed you. Got that? Okay, don't worry about this stuff. What's going on? Well, what's that? That says 6 to the power of log base 6 of 36. All right, well, do we know what that is? 6 to what power is 36?
32.
Yeah. So that says 6 squared, which is 36. Let's go 4 log base 4 of 16. What is log base 4 of 16? It's 2 again, isn't it? That says 4 squared, which is... See a pattern here? What is 2 to the power of log base 2 of 32? Any guesses? Hey, good guess. Because that is 5, and 2 to the 5 is 32. So in general, x to the log base x of y, and this isn't on our wall yet, but hey, if you want to make a poster, feel free, is y. Okay, so I'm telling you that as a rule. And what if something doesn't work? Like 3 to what power is 10? Well, it's a bit bigger than 2. It's a bit less than 3. It's not something nice. But what's the answer to this? It's 10, yeah. But let's say I don't know what that is. Okay? What can I put that in? That's an exponential form. It is, because that's an exponent, log 3 base 10. How do I put that in log form? Log base 3 of the exponent is, log base 3 of, yeah, that's the exponent here, is log base 3 of 10. So looking at that, do you see what x has to be? Yeah, x is 10. Okay? So, but if you notice the pattern here, I think I said that wrong, but anyway. Okay, I'm trying to prove it to you, but stick that in your noodle. That's helpful. And again, it's actually, I'm going to teach it like it's in tomorrow's lesson, okay? But that's a little trick. And that's how we can solve these things. So you do that for your lesson. This is the answer. Check it. And then in the work today, when you get to number 3, just do A to C. Okay? Everything else is all right. Okay, one more lesson, guys. Day of review. I got nothing really to hand you. Have a hard enough time making your test? Test is Friday. I got quizzes to hand back too. You want them now or later?